I'd like to introduce HotMesh, a serverless orchestration platform. But perhaps the best way, my favorite way to talk about it, is as a database orchestration platform. It converts any standard database, and that can be Postgres, Redis, into an orchestration server, all without adding infrastructure. If we take a microservices network, let's say something inside the VPC, what happens with teams is as they grow, they connect these service to service, and you get that tangled knot. And teams, this is where they'll turn to a central orchestrator like Temporal, and they'll install that or use that service. What HotMesh does is deliver that same functionality, but it just uses the database. There's no infrastructure to install. So really the process of untangling that mess really is not about adding infrastructure. It's about installing a package. It's authored to be a drop-in alternative or replacement for Temporal, and you can see right here, if you import from HotMesh instead, all of that standard SDK that you would be familiar with is all right there. In order to make this example a little clearer, I think it's always best to just do side by side, right? Not what's different, but what's exactly the same. And so what I'd like to do is start by describing how to actually deploy this and what it looks like side by side. Here's the HotMesh package. It's what we'll be covering. It's about a meg, and it runs as a router. There's no other infrastructure. You just download this package. You drop it on any microservice you want to be brought into the mesh. And anywhere it lives is part of the mesh, but it's just a package. All right, so how do we do that? I put together a Git repo, and it all started with a Temporal demo. And really what we do as part of this is just run a standard Temporal workflow, but I also ran two other engines, the HotMesh engine, which is a low-level engine that really runs everything, the entire platform. It's serverless, and Meshflow, which is its Temporal drop-in alternative. It's an emulation that's authored using HotMesh. So if you're a Temporal developer, you would use Meshflow. It's just drop-in and effortless. But if you ever wanted that really little bit of extra speed, you might go with HotMesh, and I'll cover both of those examples in the demo. Let me go to VS Code now for the remainder. And if we look over here in VS Code, I will start with the Docker Compose because that's really where it all begins with the infrastructure, right? This is a standard Temporal project. I included the Postgres database, the Temporal app server, the Temporal admin server, and Temporal UI, the dashboard, so we could see the results. I also created a node environment here and installed Express so that we could have an HTTP test harness to run this workflow. Now the packages themselves, if we go over here, in addition to that infrastructure, I did install the Temporal client worker and workflow libraries. And you see those here. So taken together, that is sufficient to run a workflow, which you see here. Here is the Temporal example. You'll see proxy activities. You'll see 3 calls going out. For those not familiar with Temporal, what's great about it is that you can call any function, and here is my sample. All I'm saying is hello, but imagine this is a buggy or unpredictable endpoint. And the last thing you want to do is to have everything be wrapped in try-catch as you try to corral these multi-service calls as they go down, etc. So Temporal solves all this for you. You don't worry about it. You just put in some configuration policy, and it takes care of the details. Right, so I ran this workflow in Temporal. I stood this up, and if you look over at the test harness, let me go over here. If I click there, there it is, running great. And we can, if we go over to the dashboard, we can see that last workflow run. Let's see right there. Perfect. So really easy to set up. Amazing, right? And it worked exactly as expected. Let me close that. And the process, going back to Visual Studio to stand up Meshflow, again, there's no infra, so I installed just that HotMesh package, that 1 meg package over from NPM, and that's right here. Once that was installed, I copied or duplicated the Temporal workflow folder and renamed it Meshflow, and that's this right here. And you can see that same workflow. So here's the Temporal workflow that I started with, written or from Temporal, and here is the equivalent. So that will run the same. It's a drop-in, and again, the only thing that was added was that package was installed to the to that node container. All right, and the final bit will be HotMesh, and it's pretty much the same. The difference is that HotMesh uses a YAML model, and of course that's not fun to learn. And even though it's fast, and it's really fast, what it's really great for is to expressively build something like the MeshFlow temporal emulator. And that's really what makes it great for developers, because it's just a drop-in replacement. So that's all that happened. I went ahead and I created those two other engines, but it really is a copy and paste. I'll come over here, I'll come back to my thing, and let me see, just run each of these. I'll just click on combine. We'll run all three in parallel, and each of which runs these proxied activities in parallel. So we have a lot of parallel work going on. It's great to see that all happening on the same server, all side by side, no sort of side effect. And if we look at the HotMesh dashboard, let's go over and look at that. We can take a look at the results. So I am going to look first at the MeshFlow demo. Let's look at just the MeshFlow records, and let's take a sample and look at some of the details, right? We can see those three proxied activities, greet 1, 2, and 3. And we can see that these ran over and over again as we ran that sample, right? And if I were to, go over and run that again, I would see another one appear. So let me go ahead and just run MeshFlow, right? And if I come back to the HotMesh dashboard over here, then if I refresh this, there we go, then that latest one is going to come in. If we want to look at HotMesh, again, that's the lower level environment. We can move over here, but before I do that, let me just bring up again some of the other features. We can see here the expanded telemetry output. This is info mode. We can also go debug mode, but a lot of times less is more in these cases. You get too much information, but this is a very detailed look at the various proxied activities. I'll go back to the dashboard. Let me look at HotMesh, which was the other demo that used those YAML models. Let me close that and pull one of these up. So you can see hello, Alice, Bob, Charlie. If we look at the telemetry, we're going to see a little bit different. The activities themselves are reentrant, and so you don't need to have all of that sophisticated complexity that you saw from the outset. Each one of these worker activities is actually imbued with retry policy, if you will. So in a nutshell, what you get if you really want to suffer through the YAML is if you can get that very expressive syntax. Again, it runs as routers, so if you ever want to know what's going on the network, click over and look at the network, see who's out there. We've got a worker running, we've got some engines running. So that's the view from the router's view of the world. And importantly, that router view of the world means there's no infrastructure to install, even though you're getting the same outcome. This is another excellent resource to go to. They're all here in the HotMesh Git repo. But if you want to take a look at any of the standard patterns that Temporal has, you can run those just by calling either npm test or run test and then target the specific one. So if you wanted to see, hey, what's it like to sleep or to interrupt a flow, here's a great one, the kitchen sink of everything, right? So this one will demonstrate, for example, what it's like to create a workflow, a temporal workflow, right? But in HotMesh that does all of these types of things like random numbers and sleeping and waiting for and hooks and signals, and it's the whole enchilada. All right. So just to conclude here, it is orchestration without the platform tax, and I hope you give it a try. Thanks.